Hello everyone, I'm Xiaogan. Okay, in this lesson we will implement some of the document we discussed last time. Actually, the content of this document is quite extensive. We'll still follow our standard workflow and create a folder. Okay, let's call it player camera board. Okay, then we create a new level. We won't use this level anymore. We create a new blank level. Then we save it. We put it here. We call it L player. Okay. Then after entering, actually pay attention. Sometimes in the default interface, it doesn't have our logs, and we also don't have the world outliner. You can see that in the world outliner position, it hasn't specified a game mode. It is actually using this game mode. You see that right here there is game mode base, and we actually pay attention to our location. When we haven't started yet, these are some model objects, right? This is directional light, exponential height fog. This is skylight. This is the sphere, sky sphere, and this is scalar match. It should also be used for some environmental stuff. It probably has a texture. Yes. Never mind. And this is volumetric fog. Right. This is our floor. Play a start. Okay. After we enter this place, actually, you will find there is a default pump here. This is it. Actually, we can't see ourselves right now. Right, can't see ourselves. But if we exit, after exiting, you will find that there is a small black ball here. So what exactly is this small black ball? You can observe it. It is actually the default pump class. The default pump class is a very interesting class. It is often here. It is actually a simple implementation. It has collision, and it is a flying type. So it is a class like this. It is a default one. And if you want to see it at home, what should we do? It is also quite simple. Just do it like this. Let me bring it up and show you. Because it is here. You can see it here. It is just a default point. Then there are some simple things here. MoveForward and MoveRight. Okay, then we'll bring it here. Let's go back to our document here. Then on our side, first after we have the map in place here, we need to create a new C++ class. So this time we'll use the C++ class approach like this. Then we just let it inherit from the framework. Then we'll call it. Let's use the engine's name. Okay, like this. So it won't conflict with the engine. Okay, where we place it may need to create a new folder. We create it here. Okay, you can see it was quickly created below. Actually, in this case, our editor hasn't responded yet. It's still waiting for VF, maybe giving it a callback process. We can wait patiently a bit longer. Okay, we won't give it. We'll basically close it, then reload our project. Note that it reloads here. You will see it has one more thing than our actor. Look at it. SetupPlayerInputComponent. This part as an input component, it will call a method of a parent class. This parent class method actually does nothing here. So what should we do next? From now on, we first need to declare the components we will use. This is a composition-based approach. We often say composition is better than inheritance. The point is that composition is very flexible and diverse. Then here we just attach it. And note that this is a forward declaration. Also, this static mesh, it's better to forward declare the static mesh as well. Okay, actually compiling now should be perfectly fine because compilation is quite fast on my end. I'll just make it up directly because it only declares this class. It won't report any other issues to you. Then, after compiling and adding this class, we need to use them. So as a qualified programmer, you need to manage the corresponding header files. We can take a look at where it is. Note that we switch to the header file, looking at it this way. It is like CameraComponent at this position. Inside the engine class, let's check again. Coming over here, CameraLS obviously changed its name. Obviously, this example might be from an older version. Such a vision, then note that we also introduced the StaticMesh. And this StaticMesh is on top of the components. This StaticMesh and be dipped. You might say, I can compile and pass without listening at home. Of course, that is completely fine, but in some cases, it will hide some issues. That is to say, when you go to package this plugin, there will be a problem. That is, there are some of our miscellaneous clauses that must be manually included. Otherwise, when it hits the plugin, it won't find them. Obviously, the include location here is problematic. 就释放, okay, that should be fine. Then, in our respective functions, we first need to create the instance of this component. So, right here, we have created all 3 instances. And actually, you can change its name here. We can directly change it to use component. We'll call it mesh component. We won't touch these last 2. Let's observe for a moment how it reacts in Blueprint. Then here, do a simple binding. Here, you can see this binding function is like this. Let's look at its comment. It says an initialization binding. It binds to this socket, and when this component registers yes, then pay attention to this sentence. It means it is bound in the constructor. Yeah, and it must be registered to do so. That's what it means, okay? So the binding is at this position. Here you can see what the socket lamp is. It's called SpringArmComponent and is bound at this position. So obviously this thing is on the SpringArm. Something on the SpringArm. Here we can search for it. It might be a bit hard to search here. We can just search in the current context. That is, this is actually a sock limb on the SpringArm. It is specifically bound to the tail end of the SpringArm at this position. After binding, we just need to do some simple initialization. For the variables inside, you see it is here. Here it is set to a relative. It is a method from the sync component. It sets the relative parent position. There are some other parameters here. We will ignore them. So we let it set the position of this Tanhuang B to this position. After setting it, the length of this Tanhuang B is also set. Then this delay is started. The delay time is 3 seconds. Finally, we also need to allow our player to accept its control. If you don't let it accept control, you will find that it is just an object in the scene. It will not change our perspective and control. Then after that, we will go to the blueprint to observe. Let's start it now. Cool. Then let's wait and take a look at version 5.4. This old input method is mostly usable, but it should still be usable. But ideally, when doing testing, you should stop using it. Then here, there is a player camera. Then we might need to open a new level. Let's go into this level, or we make some adjustments here. Simply, this camera seems to be misspelled. Find an A, it doesn't affect us. Then we found this place here. Drag it in. Then you can observe here, it actually looks like this. Its name, look at this name after it. It actually changed. You can see, right, it was originally called SpecMeshCamera. You can also pass in xt later to change its name. And actually, look at this position now. You can see this position is for light entry inspection. It doesn't look very comfortable now. We usually create a blueprint subclass. After creating it, we drag it here. We will no longer use it. We still use our blueprint subclass. This makes it easier for us to view. Pay attention to this position. This is actually our default interface. Here, you can see some parameters here. You see this 50-60, right? This 50-60, remember the knowledge about rotator we talked about? You can see that the order of rotator is pitch, yaw, roll. But in our blueprint, it is roll, pitch, yaw. So here it is the same. It just means the order you see is different. This is a small detail. You can see this spring coin has a length of 400 and it has an undable. Here it is 3. So basically this is a simple number. Then we can see there is an OR tool here. This part automatically accepts player 1's input method. Right. Now, let's say we start it up. You will find that we have nothing now. Then we might need to specify a static mesh here. Let me delete the models first. Then here we specify a triangular pyramid. Okay. You can see its relative position is like this now. Actually, we are not quite satisfied with it, because we want to make a modification, so we need to configure the mapping. Then, in project 13, find our input. Then you will see these action mappings and axis mappings. They are deprecated. Please use this enhanced input mapping. However, we will still demonstrate it here for you, because we will perform this action in the official new latest end demo. And obviously, when we do the mapping here, we better add the ZoomIn first. That is an action. As for the name, let's check. We call it room in. So this is an amplified timbre. Click here and there is a key. Let's click it. Okay, it can be like this, but you can rotate it like this. These are all relatively simple. Then we add 4 of them. They are respectively the WASD keys on this keyboard and also the main mouse. Obviously, this is our MoveForward. So the name here must be entered correctly. If the name is entered incorrectly, when you do mapping, it does mapping through this self-contained area. It often calls. You can add another reference here. Then next rewrite. This is a 2D one, right? Yeah, right. That is, if you type the name wrong, when it does mapping through self-propagation, when it looks it up to reflection, it won't find this thing. This is a mistake I often make. So generally, when a problem occurs, I first check if we missed something, typed wrong or left out. This is a very common one. That way, you won't have any issues when asking others. It's not easy to choose the X here, so just select it like this. We use X to space its P7 axis. Then we use to control its sub-axis. Here, okay, pay attention to the positive and negative values here. Right, sometimes it might be reversed. Just make a slight adjustment like this and it'll be fine. So at this point, our input binding is done. Finally, we need to respond to this input. So let's save it. We cannot move yet. This is very normal. Now let's bind this input. We need to, within this member variable, define some variables that we will use. Right, let's put it down here. So these variables, actually, the first one is used to receive our WASD input using a 2D vector here. Makes it easier to manage. And this is for the camera's X and Y axes. That is our zoom factor. And this is whether to zoom. I personally like to do this here. Make it solid. As for this square shape, we give it a 1.0 mf. But you don't have to make it solid, because when you use it later, you will definitely do a simple copy. At this point, we need to create some functions like this. As for this function, we just split it over. We create it again. We make it partic, because actually this function is not for external calls, right? We respond internally. This is actually a landscape-oriented idea. At most, I expose my adjustment factors instead of directly exposing these functions. We can handle it all at once. We directly create all these functions in one go. Then you will see it has already been created. After it is created, we set a limit. When we move forward, it will pass in a value. Then we take this value and copy it into our moment. At the same time, we create an math client. This math client is one of our math classes. You will find this math class is very interesting. It's called Unreal Math EL. It is located within math. So where exactly is it? It's still inside our core. It belongs to our lowest level core module. It inherits from Plant Math. Plant Math defines Windows Plant Math here. Let's take another look. If there is Windows on this side, then we click on Windows. Actually, there are no other platforms. Of course, there are definitely other platforms as well. So this is a very common cross-platform handling. Then here it provides you with some very common functions. These functions are in Blueprint. You can call them as functions, but it might be mapped here through other means. If we call it from C++, we can directly call this FMath for Blueprint. We still need to use our keysmith to call it. That's also normal. Then look at some random points. Right. Okay, this function is one we use often. It's just that we cannot directly determine whether two floating point values are equal. We usually subtract them and check if the result is close to 0 to make a judgment, because floating point numbers have precision issues. Actually, okay, so here we use an FMath to make a judgment. Similarly, for the y term, we also need to impose a limit on this value. So a semicolon needs to be added here, no problem. Then also apply a simple limit to the y term. Then this is a camera's pitch camera. And do your camera, here it directly assigns this value, no problem either. Yes, this way he can adjust it directly. Then, when we press this key, we want it to zoom. When we release this key, we are doing a false, because this is action mapping. Why is the enhanced input system much more convenient than the old input system? Because with our old input system, if you want to implement key rebinding in a game, for players to change, it is particularly troublesome. And also, under different circumstances, you may have different response methods requiring you to write complex logic. For example, in scenario A, you are driving a car, so your mapping method is forward, backward, left, right. Then in scenario B, you are flying a helicopter, or diving, or pulling up. So when you have to write a lot of logic at that point, you need to write a complex mapping system yourself. If you use the growing input mapping system, these methods can all achieve this flexible registration, as well as aspects like rebinding keys. So this is the approach of the new input system. Then, after we create the function, we have only written an intermediate state. Then it calls water. It changes water, but it hasn't been implemented yet. So actually this part achieves a bridging role. Then bridging the latter part means by changing this value, monitoring this value in tick, then modify our current position and our current scaling. The state of this actor. And front end means accepting input from our 10 keyboard and mouse to the things in this input. Now let's start a simple front end operation. Very simple. Let's first write our axis mapping. Let's first write our axis mapping. It's here. So, obviously, this is what we just called in our blueprint, right? Why is there no room out? Because it makes a change through this place. This place, it is a way to bind an action. You will find this place passes the name of the action. It is a flam. We know flam. It is case insensitive. It is a unique string. Then let's read this comment carefully. Find a delegate function. Then through this action mapping, it is defined in particle 13. Then it returns such a bound application. The validity period of this application, that is, until another binding occurs, it is useful. At the same time, then this place has some more complex things. We haven't covered it yet. So this is eWoman. It is clearly an enum. It defines a state for such a key. Press and release are the most commonly used. There are also double-click or access-related things. So this user classics object, it is a template because it doesn't really know what we are passing here. Let's take a look. Let's take another look, because it doesn't really know what kind of thing you will pass. It is a pointer. That is, because you bind it. There are many objects in your scene. So which specific object are you binding to? Right, then it needs an object to specify this pointer. After specifying this object, right? After binding only this object, then a function will be hooked in here. Actually, this is a function. It is written very long here. Actually, this is a function pointer. That is, it points to this location, because you know all classes. In fact, their functions are only stored in one copy. This points to the address of the function. Okay, then there's no problem with that. Still using this function name plus these two colons. Then add this object name followed by the function name to specify it. Then pressing it at the same time will trigger it. It will trigger when eating. In fact, this also serves as a kind of pre-existing function. And at the same time, we have this action mapping. We also have this axis mapping. Obviously, the axis mapping is when we press the main key. Often we have operations where we hold down the main key. You can see. Then the parameters it accepts are also the same. This is our name. Okay, this is the pointer to the instance object of which specific actor and who is doing it. Then what kind of method does it need to execute? Okay. So in this case, we have moved forward. Our forward movement is now complete. Then we need to perform a simple follow-up in the tick. As for the follow-up, we will first handle its scaling. Perform a simple follow-up. We directly take the monster. Let me explain again. That is, we will listen to this boolean. Here, if we write it like this, it is fine, because we are receiving it in the main thread. Receiving this. That is, we are modifying the same property value within the same thread. Then it won't conflict. This place is the mainline layer. This place is also the mainline layer, so there is no problem. They actually have a sequential order. So there won't be a situation where, actually in this frame, I might have processed my input first. And then this place changes. It's also possible that this was processed first, and then our input was processed. All of this is completely fine. In a multi-threaded scenario, you cannot directly use this simple boolean. You might need to use some thread safety aspects processed by category. So here, this is in the press state, we keep increasing the imprint value. And if it is already increasing every frame, and if it is already released, then decrease every frame. Set a limit here. A limit, right. And here is a Lerp. Look at this Lerp. It actually performs a linear interpolation between two values. It's A and B, and this is from 0 to 1. When it's 0, it's the first value. When it's as, it reaches the value B. If it's in the middle, you can see the math calculation is quite simple, from A to B, and it's a generic type. It looks a bit uncomfortable, but it's a generic type. No problem either. You can take it into the C. Substitute it as this float value. Obviously, when it equals 0, it's the value A. When it equals 1, then the negative part with the previous base, it's the value B. So here, this square CO character, we clamp it between 0 and 1. Then we interpolate through this Lerp. We set its faux between 90 degrees and 60 degrees. Obviously, our faux, the smaller it is, the clearer we zoom in. And this is a SpringArm value, right? We pull it closer. So it approaches a value of 1. Then the value of 1 obviously zooms in more clearly. And this kind of writing, actually, we don't really recommend it, but writing it this way is not a problem. We can delete this, because this way of writing will cause a problem. We mentioned earlier, that is, your nesting is too deep. It can actually be quite hard to read sometimes. Okay, here we have handled this action sound. Now let's handle the direction sound. Now, for this part, for the axis mapping, we'll handle the camera first. Let's handle the camera first, then get our current actor. Because of the hierarchy of this camera, it has a grandparent-parent-child relationship. That is, the grandparent moves. Then it will move the father along with the son. So there is no problem with directly moving the actor. So here we are going to take this the camera input directly modifies the actor. Then it moves both the actor and the camera together. So there is no problem here at all. Then when we set the pitch value here, we probably won't pitch this object directly. So here we only need to modify the SpringArm. Note that the name here may have changed again. We need to do this. Then it applies a limit to this pitch value. Because when we pitch, it actually has a major limitation. If you tilt too much, it will make your entire operation feel very chaotic. This is a 3C posture. That is, you cannot rotate 360 degrees while tilting. That is, when your tilt camera turns to directly above or below, it will mess up the entire axis. So it basically applies a simple restriction. In this part, it actually only changes this spring rotation restriction. Then next, we will handle all wired controls. Okay, this part actually handles it all at once. It's also quite simple. Let's take a look. This place actually goes to... Hey, take a look at this. What is this flow mode thing? It seems there is no such function. This side is getting our current. Getting the position of our current actor. And then this is movement. This is where we set a variable. Actually, if you haven't set this variable, it should be set to 0. But it actually magnified it by 100 times. And this place actually wants normalize it. This place should be trying to normalize it. Everyone uses this. This method is quite common. We can click on this function. You will notice that here, it no longer uses this. It uses a gate because what the engine likes to do most is to strictly follow this gate set approach. That is, if there is a member variable in this class, it will definitely make this member variable protected. And if you want to access it, it will expose get and set methods for you. This is a very standard design approach and philosophy. But if often, when we upgrade from version 4.24 to 4.25 or 4.27, you will find that the member variables you could directly click on before. Now we must operate using the escape method. This is very common. This should actually be a normalization. After normalization, then at this point, then apply a scaling modification to it. And here it is multiplied by the influence of this time factor. Okay, then finally set the value of this actor. So actually at this point we are done. Now let's demonstrate this effect. This part should be relatively simple. Let's just finish it all in one go. Of course, there are actually many details in this. I have already emphasized them to you. This emphasis, for example, this lesson is still quite long, about half an hour. Okay, let's pay attention to the level of detail here. This kind of graph is actually a data-only blueprint. A graph is a great, excellent blueprint graph because you only modify data or you don't write much logic. So, if your blueprint looks like this, that's okay, great. Then as for this hierarchical relationship, we won't emphasize this hierarchical relationship. Then let's do a simple test here. Now let's test the pitch angle. You can see all x is the pitch angle. These are x, right? Then you might find it a bit unfamiliar. Then our y value is its rotation. The y value is a rotation. And now our eyes to movement is also completely fine. You can adjust some small details yourself if you're not used to this kind of thing. Okay, we'll stop here for now. Thank you, everyone. No, it seems we haven't covered the zoom out yet. Yes, you can see. So to make it clearer for everyone, we can do it this way. Let's adjust it. Let's change it to sprem. Right here, let's start it again. You will notice we might need to do it this way. We press Shift plus F1, F1. We can bring it up. You can see, right? There's absolutely no problem with this. Okay, we'll stop here for this lesson. Thank you, everyone.